Alexa, tell work I'm here.
Okay, welcome to work. I am Alexa, an Amazon Echo device. This video will show you how to teach me skills and use me to control things around you. I am really cool once you get to know me. Should I go on?
Yes.
To program me, you don't need any special software, just an account with Amazon Web Services and a computer with internet access. You can even trick a Raspberry Pi into thinking it is me or use the Alexa simulator. Effective but not as cool. Our test will use a WAGO PLC to control this light. Let's get started.
Now, in order to build this entire skill, we need to understand all the components involved. First, we have our Echo device, which is using our AlexaSkill kit. It's publishing data into our Node.js script in Lambda. It's then creating an MQTT message that's being sent into our AWS IoT thing, specifically into the thing shadow, and I'll explain a little bit about what that means. And then we have our hardware device, which is subscribing to the MQTT topic, which is our AWS IoT thing shadow. So all these components are working together to create our full skill. The way that we're doing it right now is it's fairly unidirectional. Once it gets into our Lambda script, we're publishing to the thing, which is publishing to our PLC. We could close the loop and send data back into our thing, which would then send back into our script. But we're going to keep it simple and just follow this model here. Our next step will be to create our AWS IoT thing. This is going to be really the relay between our Lambda function, all of our functionality, and our hardware piece. So we're going to build it a little bit. We're going to build our whole model a little bit backwards because we need the target to be able to send that data to. So what you'll want to do is navigate to console.aws.amazon.com. Make sure that you're logged into the East server out of North Virginia, which is the server that's been dedicated to handle Alexa voice skills or the Echo voice skills. If you're not logged into this, it will not work. So we'll select AWS IoT. It'll open to this nice new dashboard, but all we really need to do in this is go to Registry, Things. We don't have a thing created for this application, so we're going to go ahead and click Create. And I'm going to call my thing PFC200, which is the hardware device we're going to be using from WAGO. There are options below if you wanted to assign a thing type and attributes, but we don't need to do any of that. We're just going to go ahead and create the thing. It'll pass us an ARN number, which we don't really need that right now either. All we really need to do here is go to Security, create a certificate, which will create all of our keys and our PEM certificate. We're going to download all of these. And if you don't have one already, you'll also need to download a root CA certificate, which is made available here. If you right-click on Download, Save Link As, we actually want to rename this. We want this to be root-ca.crt, and we're going to land this in our Downloads folder as well. So we're done with this. We don't need to do anything else with our AWS IoT thing. Next, we're going to build our Alexa voice skill. And in this skill, there are a few different things we need to know. We need to know how this skills kit interprets our utterance. And our utterance is really the phrase that we want to tell the Echo device or our Alexa device. So our example is going to be the utterance, Alexa, tell work I'm here. And in this, there are a few different components. Number one, the wait call for Alexa. Anytime Alexa hears Alexa, if it's set up this way, it can be either Alexa or Echo or Amazon, but it's always going to be one of those three. We'll say Alexa, which will wake the device up. Next is going to be our invocation. So the invocation is going to be the phrase that's going to call our specific voice skill. So in our case, we're going to say tell work. Work is actually our invocation. Once it hears the term work, it knows that it's going to call this skill. And then lastly, we're going to use a piece of data in this, tell work I'm here. Here is going to be data that we're going to pass into the slot. So here we're going to call it a direction. but this is just data that we're going to be passing into our Lambda skill. So what you want to do is navigate to developer.amazon.com, sign in to the console, and it'll bring you to this developer console. We're going to select Alexa, and we're going to go to the AlexaSkill kit. We don't have a skill in here yet, so we're going to click this button. This is Add New Skill. We're going to call this skill Alexa at Work to try to keep things consistent. Our invocation name, as we discussed, is going to be work. So if you read the verbiage here, it's, for example, Alexa ask tide pooler. We could say ask work, tell work, but work is our invocation name, meaning when it hears work, when the Echo hears work, it's going to start this skill. We'll save this, and we'll move on to our interaction model. So our interaction model really, two things are apparent here, intent schema and the sample utterances. Intent schema is the structure of our message and how we're going to pass this data out of our AlexaSkill into our Lambda function. Our sample utterance is going to be the actual phrase that we're going to say. We're also going to add a custom slot to ours because we want to better manage the data that's passed through. So we're going to start, though, with our intent schema. And our intent schema, I've already created this, but I'll explain the structure. It all begins with intents. So intents is the header of this schema. We can have several intents here, and that's why it has an open bracket for creating the array. But intents is our header. We've only got one intent in this, so we don't need to separate these. Our intent is going to be defined as work intent. Below that, we're going to separate this into slots. The slots can also be an array, but we are only going to be passing one slot of information back. If we had more than one, we could separate this with a comma and create our second JSON structure here, but we won't need to do that. Our name is going to be direction. So this is the intent object name that we're going to pass, and that is going to be a list of direction. This could be literal. Literal would pass the literal phrase that we're uttering. This could be Amazon.number if we wanted this to be a number value. There are many, and you can see those by clicking on built-in slots or built-in intents. For this, we're going to keep it with list of direction, which will be a custom slot, which we'll build next. We'll do that by clicking add slot type. We're going to name this list of direction. And in this, we're going to have really only two options, here and leaving. We want to be able to say, Alexa tell work I'm here, Alexa tell work I'm leaving. We'll save the slot type. And then we just build our utterance. So this is looking for the exact phrase that we're going to be uttering to this, headed with the intent. So we want this to be work intent. This is going to be the identifier of this utterance. And we've already got our invocation name, which is tell work. And so all we have to do is put I'm direction. You'll see it's already doing some error checking for us. It'll turn green. You'll see the curly braces turn green. When they're matched, if I don't have them matched, they're red and they'll show us an error. The same thing goes for our JSON file up here. If we mess up our structure, it'll give us an error. So it's really it's well organized in that way. So once we've created that, we'll make sure we're error free and we'll click save. We missed the brace here. It won't let you finish until you've got this correct. So we've built that. This is all complete. Now when we say Alexa tell work I'm here or tell work I'm leaving, either way it will capture that data and send our value from our list out to our Lambda function. So once we've done that, we're going to go now to configuration. And this step will be to point this towards our Lambda function. It's going to ask for our Lambda ARN, or Amazon resource name. We've not created our Lambda function, so we're going to hold this part at this point. We're going to go into Lambda, create our Lambda function, then we'll come back and finish this data. To create our Lambda function, we'll need to go to our AWS console. It's a little confusing because we have our developer.amazon.com where we create our AlexaSkills, and then our console where we have all of our other tools like the AOS IoT device, Lambda, IAM, which is our really our roles and policies, and CloudWatch, which allows us to monitor a console to do some debugging with the Lambda functions. For this, we're going to click on Lambda, which is going to take us into a list of Lambda functions that we've created. If you've got nothing here, you just create a Lambda function. I've got some functions I've already built, but we're going to build a fresh one for this AlexaSkill. We'll select new function. We're going to build a blank function. And when we get to this, we're going to be able to select a trigger. So you've got a lot of different things you can trigger from this. If you want to trigger from CloudWatch logs or database things, you can do that. However, we're just going to trigger this from the AlexaSkills kit since we've already created our utterance there. We'll click Next. Now this is our function configuration page. It's going to default to the inline code editor. We're actually not going to use this. But first we're going to name our function. We're going to call this myAlexa@work function. The description, we can put anything we want in here. I'm just going to put Alexa work. We're going to leave this as the default runtime, node.js. This is what we're going to be using for our function. And as I said earlier, we're not going to use the inline code editor, at least not at this point. We're going to upload zip files that we've created externally. You can also bring in a file from Amazon S3, which is the file server. So click upload .zip file. I'm going to make available the zip files that I've created for this in public repository. You'll see them in the comments section of this video. But let's take a look at what these files are. I have two files in my system, or I have two files in my function. One of them is a file that I use as a generic library, essentially, for all of my Alexa functions. It does a lot of things for me already. It's got a lot of the function structures in it. It's got the request handlers. It's got the AlexaSkill already embedded in it. It has also the on intent. This function block right here, or this function, is very handy. What it does is it looks for the intent that's coming in from our AlexaSkill, and it creates a function call with that intent name. So what that means is in our other file, our editable file that we'll have in here, we'll just create functions with that intent name, and hopefully when I create that, it'll make sense to you. But some other things that this file has in it are some of our card logic, card being the actual text that will pop up when you're on the Alexa app, and then the response, the returns, the tell with card, ask with card. Those are all part of this file. But we're not going to edit anything in this. I always use this as is, so you don't really need to think too deeply about what this file does. Now the file that we will edit is our index.js. This is our main file that we'll be using. So I'll just break down some of these main components. Our app ID we leave undefined, at least for now. This could point back to your Amazon Echo device, specific to your device, so you could keep this aimed directly at a device. Leaving it undefined will allow anything to pass data into this function. Next, I've got my config object, and my config object is essentially going to be the credentials for my IoT thing. So we created our thing. We'll have our endpoint in there. You'll see the endpoint when you navigate through your thing. You'll have the alphanumeric section of your endpoint, which you're going to want to populate in here. You can just copy your whole endpoint into here, but there's some upfront information like HTTPS : / all that stuff you can edit out of there. The region, you'll want to make sure that this is pointed at US-East-1. And your thing name, so we created our PFC200 thing name. That's going to be very important to make sure that all these messages are being routed to the right place. So we're also going to create a new instance of the AWS SDK. We're going to require that in this, which is going to pull in all the functionality of the SDK, and we're going to configure this this region with the AWS object. IoT data is going to be a new instance of AWS.IoT data object, and that's again just handling credentials back for your MQTT message. We're going to create an object called sendParams_update, and this is going to be the required information to publish our data to our MQTT topic. So this is our topic name. Our payload, we're going to assign this later in our program. Quality of service, we're going to leave at 0, but all of these are going to be a JSON object, which will direct our message. And we're going to create our payload object, which is going to be our thing shadow data, which we're going to send via MQTT into the thing shadow and update that. We've got some other variables, speech output. This is going to be what our device is actually going to say. Send value, we're going to assign this value and load that into our payload object. Now, we're going to require the AlexaSkill.js that we just looked at, so call it as a library. We're going to create this Alexa at Work function, excuse me. And now we're gonna create our Alexa at Work prototype object. We're going to extend that with the constructor. We've got an on-session started function, an on-session ended function. We can clean up like context items in here if you've got retained data that you want to change. But after all that, I know that's a lot of that's a lot of stuff to go through. The real work is going to be done now by our work intent. This is the function that I've created. You'll notice that this aligns with our utterance that we're going to be passing, our intent here, work intent. You'll want to make sure that lines up with our function. So just stepping through this logic a little bit, we can play with our intent as an object. So if intent.slots.direction.value is equal to here, our send value is 1. So you remember that we created those slot types, and that slot's either going to report here or leaving. If it's here, we're going to have object or a send value of 1. Speech output will be okay, welcome to work. If it's not here, we're going to assume it's leaving because we've only created 2 in our list. Send value will be 0, and she'll say goodbye, see you soon. We're going to take those values and we're going to put them into our payload object. So payload object.state.desired.topic that follows this structure here, state desired topic equals work. Payload object state desired command will be change. Payload object state desired value will be send value. We're going to update the payload of our send params. So this is the data we're sending out. We're going to call this method json.stringify payload object. So it's going to take that whole JSON object, convert it into a string, and put it into our send params update.payload. And then we're going to publish that to our MQTT topic. So IoT data.publish send params update. We just updated that. It's going to carry that out. If there's an error, it's going to console log MQTT error plus the error data. Or if no error, it's going to console log our data It's going to console log our send params update payload, and it's going to respond with our response that we've loaded. This console.log method is really useful for debugging. You can go to the console log. In fact, I'll call this up so you can see what this looks like. It's under CloudWatch. You can go to your logs. We'll pull up Alexa at work, and you can see what these logs look like. So we've had some successful runs of this. Here, for example, is the topic that we've sent. If it's errored out, you'll see some error messages. Here's one example. Error at function module. It's missing some scripting in there, so you can follow these logs to really help you out. So this file should be very intuitive to you. Go through it, read the comments, see the flow. It should be very intuitive. If you want to add another function to this, what's easiest to do is to copy the text I've already got here. You'll want to make sure that you put a comma after the closing bracket of that function, and you can just paste another one here. A lot of this code can be reused if you just want to rename this intent to, hello world. You could do that anytime you made an intent of hello world. It would call this function. So we'll go back to how this was. What we'll like to do is we'll want to open the file where we've got this. This is our at work with Alexa, and we'll want to take these files here, and we'll want to our index.js, our AlexaSkill.js, and we're going to go ahead and want to compress these together to create an archive.zip. Now we'll go back to our Lambda function, and we're going to select upload. We'll make sure we're on our file with our archive.zip. Select that file, and we're going to go ahead and load that. Now, moving down, we don't need to do anything with the environment variables. We don't need to modify the index.handler. We're going to just choose an existing role instead of creating a new role. And our existing role will be Lambda basic execution. So this is our standard Lambda role. We don't need to change anything else in here. We're going to click Next, verify all this information is correct, and create function. Now, I used an older file which did not have my updates with my IoT thing, so I need to update my name here. You'll see once we've uploaded this, we actually have access to our index.js file, so we could go in and modify this. This is a really nice JavaScript editor, actually, and so if we have JavaScript errors in our code, it'll report those. For example, if I just put a semicolon where I shouldn't, it will give me an error in the line. It'll also tell me that what that error is. So you can actually work from this file here. It's really nice once you've written the bulk of your code and you just want to make some minor changes. You can do all of that here. So we're going to go ahead and click Save. I'm going to go ahead and modify this later on to add my endpoint. For security reasons, I'm going to leave that off. But your code should be ready to run. So one of the things that this gives us now is our ARN number that was requested by our AlexaSkill. So we're going to copy this. You always see the ARN up here up in the top. You can also get this too if you go back to your list of functions. If you check the button to the side and you go to Actions, you can request for it to show your ARN, and it'll display up at the top as well. So we'll take this ARN. We're going to go back to our configuration. We're going to select AWS Lambda ARN, North America, and we're going to paste this ARN right there in the window. So you'll see there's our ARN. So we've saved that. Let's go ahead and go to this test option and make sure that it's working. So with test, you can test your text to voice if you want to hear the way that Alexa will say that. But for our test, all we really want is we want to make sure that when we say our test phrase, that Alexa will respond. So we don't need to say Alexa because it's just the wake word, but we do need to use our invocation name, which is work. So tell work, I'm here. Ask Alexa at work, you can see it processed our request, and we also got a response. So looking in this request, we've got a bunch of data, but we go down here to intent. We see that it passed work intent. It passed a slot name direction with a value of here. And it responded with, okay, welcome to work. We can test this again and say, I'm leaving. You can see it responded with, goodbye, see you soon. So this is working. Now we want to go over to our AWS IoT thing and make sure that the data is being sent out of the Lambda function into this. So we go into our thing. If we go into activity, we can go to the MQTT client and we can subscribe to this topic. So the topic will be AWS, but $AWS things / PFC200 / shadow / update. And we should see data come through in this MQTT message, AWS things PFC200 shadow update. So we'll monitor this, we'll keep this window up, and we're going to go back here to our Alexa simulator. We'll say I'm here again. And you'll see we've got our message that came through that said state desired topic work command change value 1. This will be value 0 once we say leaving. So we're very close. We're very close to having our hardware working too. There we go. Value of 0. So once we've confirmed that we're communicating with our MQTT topic, now we just need to connect our hardware device to this. So we downloaded our certificates. You can see them at the bottom of my browser there. They're in my downloads folder. We'll open this. As I mentioned earlier, we're going to be using a WAGO PLC to connect with this. The reason that we're going to be using a WAGO PLC is because WAGO has a really fantastic MQTT library that allows you to easily subscribe and publish topics from there. So the very first thing we need to do is make sure that we have all of our the right credentials and the right access files in our PLC. So I'm going to navigate via FTP to our WAGO PLC. I should also mention that there are IPK files for this PLC. So real quick, I'll demonstrate what it looks like to add these credentials, or I'm sorry, add the some of the libraries and whatnot to the PLC. So here's a web-based management. If I navigate to software uploads, I'm going to use the admin credentials for this PLC. I can upload files in here. So if I go and I use the IPKs that are available for the for the PLC, you see I've got a MQTT and a Mosquito IPK. So I'm going to browse for these. I'll go to the directory where I keep these. First I'm going to upload the Mosquito. Open. Upload that, and then I'm going to submit. It'll activate that. Now I'm going to grab the MQTT IPK. I'll open that, I'll upload it into the system, and I'll activate that as well. So what that does is it creates all of the internal libraries that the Linux system needs to be able to connect to the MQTT, and it also creates a directory for me to put my files. So once I've done that, that's all I need to do. You'll need to power cycle your PLC. I'll navigate though to the Linux file system over FTP. I'll go to the root directory. Now I'll navigate to etc, and if I scroll down, I'll have a Mosquito folder. Here's my Mosquito folder. I just want to take all of those certs that I downloaded. I've already got a root CA folder, or a root CA certificate in there. But I'm just going to grab these certificates and upload them into my PLC. One of the things I'll need from this is this this code here, which I'll use in my PLC code. But now we can power cycle the PLC and move on to the actual programming. So the last thing that we'll do here now is we're going to actually connect this to the hardware. So we've already uploaded the certificates. We've already got our program written, and this program is really very simple. I'm processing the JSON string coming in. I'll show you what that string looks like, but I'm moving that out into some string arrays, and I'm looking for certain positions in those arrays, and then I'm just processing some logic and saying if the value of my message coming in is 1, I'll turn my output on, which is my work light. If my message is 0, I'm going to turn my work light off. So let's go back to our MQTT program just so we can look at the data coming in. We'll go on, log in with this. It should connect right away to our MQTT device. Once we run, we'll see our connected should go true, as it did. We're going to expand this subscriber block, and the data we're looking for to come in is in this data. So we're actually going to use our Echo device. So Alexa, tell work I'm here.
Okay, welcome to work.
You'll see we've got our the same data we saw in our MQTT message. We process that in our work POU. We see that our S value is 1. In fact, if you want to see the way that data looks once I parse it out into the string, it's very straightforward. I'm just using different characters to ratchet up the array position. So my state, desired topic, work, command, change, value, 1. So I'm really just looking for this value. But you can do a lot with this type of logic. We'll verify that it works on the back end. Alexa, tell work I'm leaving.
Goodbye. See you soon.
See our values change to 0. We'll test it one more time. Alexa, tell work I'm here.
Okay, welcome to work.
Now you can see how easy it is to build an AlexaSkill, an Alexa voice skill with Amazon's AWS. The WAGO platform makes it extremely easy to bring that data in and to turn that data into something usable. So I encourage you to try this out. Go build new skills, find new ways to use this technology, and with that, Alexa, tell work I'm leaving.